Chapter 3, describing data using numerical measures. Section 3.1, measures of center and location. We will study 3 measures of center and location: mean, median, mode, and then we will study also the weighted mean. You need to understand the definition of each one of these 4 measures and how to calculate them and what are their characteristics. Before we go on, we need to remind ourselves with the difference between parameter and statistic. We will talk here about numerical measures. So we will calculate numerical measures. We will compute numerical measures from the population. Any measure computed from the population is called parameter. While if we compute the same measure from a sample, then it is called a statistic. So for example, the mean when calculated from population is a parameter, while the mean when calculated from a sample is a statistic. Okay. Also the median, also the mode. The mode of a population is a parameter. The mode of a sample is a statistic.
دكتور عندي سؤال اعتذر المقاطعة.
Now there should be no questions.
طيب.
Now the population mean, let us talk about the population mean and the population and the sample mean. So we will talk about population mean and sample mean. The population mean, we are calculating the mean from the population. It is called a parameter, or it's a parameter. How to calculate the population mean? You add all the values, summation xi, so you add all the values and you divide by the population size. So capital N is the population size. And this symbol is called mu. So mu is the population mean. So mu, or the population average, is computed by dividing the sum of all values by the population size. So you add all the values in the population and divide by the size of the population to get mu, which is the population mean or the population average. So we represent the population mean by the Greek letter mu, okay? And this symbol means sum. We add summation. We add all the values, okay, where I goes from 1 to the size of the population, capital N. It is understandable if we write summation x, we don't have to write summation I from 1 to capital N. So we will usually write it like this: mu equals summation x over capital N. This is the definition of the population mean. And this is an example. This is a population of interest. Okay, the hospital is interested in only the census data for the past 10 days. This is the population of interest. So to find out whether the numbers in the question represent a population or a sample, you should find that in the question. Okay, so here in the question he said this is the population of interest. So these numbers represent the population, and the population here has size 10. To find the average, the population average or the population mean, we add all the numbers, the 10 numbers, and we divide by 10. We use the calculator to get the answer. So the average of the population is 288.4. So that's the population mean. The sample mean computed by the same way, but you add all the values in a sample. And since we compute the sample mean from a sample, it is a statistic. It's called a statistic. It is denoted by this symbol, which is called X bar. Okay, so the sample mean is X bar. What is the definition of X bar? You add all the values in the sample, sum of all sample values, you divide that by the sample size. So the sample size is small n, okay? Population size, capital N, sample size, small n. This is an example. He said in the question that this is a sample of 10 days. So these numbers represent sample of 10 days. We add to find the mean, to find the sample mean, the sample average, or X bar. We add all the values and divide by 10. So the sample mean or X bar would be 30. Now let us talk about the characteristics of the mean, whether it's X bar or mu, the mean in general, either from population or from sample. What are the characteristics of this measure, the mean? There are three characteristics. First, it uses all the data, which means to find the mean, you have to use all the data. You have 10 numbers, you will add all of them, okay? For every one of them is important. You have to use all the data. That's good. Sensitive, the second one, sensitive to extreme values. Extreme values means very large or very small values, extreme values. The mean is sensitive to extreme values, which means if this number, for example, 90, is replaced by 900 or 9,000, okay, this will affect the mean. The mean would become much larger than 30 because 90 will be replaced by 9,000, for example. So here you will have, instead of 99,000, so you will have a bigger number than 300. And then when you divide by 10, you will get a number around 800 or 900 or maybe more. The mean is affected, is sensitive to extreme values. Of course, you will understand these two characteristics, even the three characteristics, better when we talk about the median and the mode. The other measures, you will see that some of the other measures do not necessarily use all the data or not necessarily sensitive to extreme values. But now you know that the mean uses all the data and is sensitive to extreme values, and it is the balance point. What is the meaning of the balance point? It means that X bar is in the center. It measures the center, in the center. There are numbers to the right of X bar, and there are numbers to the left of X bar. Now, if you find the distance between all the numbers to the right and X bar, you will find it equal to the distance between all the numbers to the left and X bar. So this means it is the balance point. Sum of deviations from the mean. Deviations from the mean, يعني X minus X bar. This is the distance between the values and the mean. Sum of deviations from the mean is 0. Okay, summation X minus X bar is 0. X minus X bar, and you find the difference, the distance between each value and X bar. Some of these deviations would be positive because the number is greater than X bar. Some of these deviations would be negative because numbers are to the left of X bar, but when you add them, you get 0. If you want to understand this more, you can apply it here, okay? This is an example, and you can write all the values of X here, which is, I have 5, with 10, with 20, with 20, 23 times, 3 times, but then I have also 15, I have 20, there is no 25, okay, 2, 4, 6, these are 6 values, but then I have 30, but then I have 40, 50, and 90. 2, 4, 6, 8, 10. These are the 10 values. Now find x minus x bar. X bar is 30. X, these are the x values. So 5 minus 30, negative 25. 10 minus 30, negative 20. 20 minus 30, negative 10. 15 minus 30, minus 15. All of these numbers are smaller than 30. So they are to the left of 30. How many numbers? 2, 4, 6. 6 numbers are to the left of 30, smaller than 30. If you add their deviations, you have 30, 50, 65, 90. This is negative 90. If you add all of the deviations of these 6 numbers, negative 90. The 30 will give you 0 because 30 minus 30 is 0. 40 minus 30 is 10. 50 minus 30 is 20. 90 minus 30 is 60. If you add these 3 numbers, 3 deviations, it would be 90. And now when you add negative 90 plus 90, you get 0. So summation of x minus x bar is 0. This is the meaning of this characteristic, that it is the balance point. The mean is the balance point. Of course, if you also use the population, not the sample, also you will find that x minus mu, summation of x minus mu would be also 0. And you can try that here in this example. You can do the same for this example, and you will find that summation x minus mu is always 0. The second measure is the median. The median is a center value, divides a data array into 2 halves. What is the meaning of data array? Data array means data that are sorted in order. So you have to sort the data first, and then you divide the data into halves, 2 halves. The number in the center is the median. So in fact, the median is here in the center, and we call it MD. And 50% of the data is to the right of the median, and 50% of the data is to the left of the median. That means if you have 10 numbers, like here we have 10 numbers. If you find the median of these data, 10 numbers, then 5 numbers would be to the right and 5 numbers would be to the left. Okay, let us write these numbers in order. Okay, we have 5, 10, 15, 5, 10, 15, 320, and then 30, 40, 50, and 90. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the 10 values. In the previous example, they are sorted. Now, where is the center value? The number in the center. Well, the number in the center is here. Is between 20 and 20, because 5 numbers would be to the right and 5 numbers would be to the left. So the median in this case would be the number between 20 and 20, which is actually 20. But if you want, you can add 20 plus 20 over 2 and it would be 20. So the median of this data is 20. 5 values to the right, 5 values to the left, 50% to the right, 50% to the right, the left, while the mean is 30. So the mean for this data is 30, and you notice that the mean does not satisfy this property. Yani the mean is 30. 3 to the right or 6 to the left. It's not 50-50, while the median is 50-50. So that's the definition of the median, okay? It's the center value that divides a data array into two halves. If you have large number in the data, how can you find the median? Okay, so you need what we call a median index. The median index. What is the median index? It is n over 2. So I is actually n over 2. So here, for this data, the median index is I equals n over 2, 10 over 2, so it is 5. The median index is 5. Okay, so what? What if we find the median index? Why do we find the median index? We find the median index to locate the position of the median. Where is the median? Okay, if I is not an integer, in our case, it's an integer, it is 5. But assume that the numbers are 11, not 10. 11 divided by 2 would be 5.5. It's not an integer. What to do? Round the value up to the next higher integer. So 5.5, round it up to 6. Now the position of the median would be 6, which means the sixth value you are arranged the data 1, 2, 3, 4, 5, the data number 6. If there is another one here, for example 100, then in this case this 20 would be the median, the data or the value number 6 in the data. While if the index, if the median index is integer, like our case, like here 5, it's 5, then the median would be the average of the value in position I and position I plus 1. So this is value number 1, value number 2, value number 3, value number 4, value number 5. Value number 5 is not the median. No, you have to take the average of value number 5 and value number 6. Okay, so this is number 5 and this is number 6. So you add 20 plus 20 over 2 and you get 20. Of course, because this is 20 and this is 20, the answer would be the same if you take 5, take 6, or take the average, but this is not necessarily the case. Usually you have different numbers here, not equal numbers. If you have equal numbers, it's okay, but if you have different numbers, you have to use this fact. No, you find the average of 20 and the next number, which is also 20, the average of the two values in position I and in position I plus 1. Let us take some more examples. Here we have data sorted and we have 10 numbers. So where is the median? Find the median. How to find the median? It is sorted. That's very nice. One step is done for us. Now we immediately find the median index. I have how many numbers? 10. So 10 divided by 2 is 5. So the median index is 5. So I go 1, 2, 3, 4, 5. It is an integer. So I have to take the average of the 5, the 5th position, and the 6th position. So the median would be in the middle between 35 and 45, or 35 plus 45 over 240. So that's the median. So the median is 40. 5 numbers would be to the right, 5 numbers would be to the left. If we have 15 numbers, 15 customers like here, these are 15 numbers sorted from low to high. If it is not sorted, you have to sort the data first and then find the median index. We have 15 numbers, 15 divided by 2, 7.5. This is not an integer, so you have to round it up to 8. And now where is the value number 8? 1, 2, 3, 4, 5, 6, 7. This is the 8th position. So 85 is the median. So the median is 85. Now if you count how many numbers to the right, it would be 7. How many numbers to the left? It would be 7. So 7 to the right, 7 to the left. The median is in the middle, the center value. That's the definition of the median. What are the characteristics of the median? We have to order the data, okay? Ordered array, lowest to highest. If you do it from highest to lowest, you will get also the answer. But we usually use from lowest to highest. The median is the middle number. It is in the middle. 50% of the data above the median, 50% is below the median. That's really the definition of the median. We call it MD, and it is not affected by extreme values at all. It is not affected at all by extreme values. And for example, we mentioned if you change this 90 to 9,000, the mean will change, but the median is not going to change. It is 20. If you write this 9 million, the median will be also 20. So it's not really affected by the extreme values, okay, the values that are larger than the other values in the data. Also, it uses only the middle values, the median. So it doesn't use all the values like the mean. It doesn't use all the data. No, it uses only the middle values. So I here used 20 and 20 only. In this question, I used 35 and 45. In this question, I used 85 only, and I did not care about all the other numbers, except I arranged them. So if this is 99 or 99,000 or 99 million, I don't care really. The answer would be 85, the median, because I used only the middle value in this case, or the middle values if n is even. The last measure today is mode. Okay, the mode. The mode is very easy. It's the most frequent value. Okay, the value that occurs most frequently, repeated more than all the others. It is not affected by extreme values, the mode, because you only count the number that's repeated more than the others. So if there is 1 million in the data, he doesn't care, the mode doesn't care. Can be used for both quantitative and qualitative data. This is very important, very special characteristic for the mode. The mode can be used for qualitative data. Qualitative, not numbers. For example, colors. If you have colors, white, red, white, yellow, white, black, white, then white is repeated more than all the other colors. So white would be the mode. But you cannot find the mean of colors. How can you find the mean? You can't. Of colors. Or the median of colors. You can't. But you can find the mode. Okay? The mode is very special here. You can find the mode of qualitative data. And you can also, this is also very, it's very special here also, you can have more than one mode for some data. And for example, if you have the data 3, 3, 4, 4, 5, 6, 7. Now, which value is more repeated here? 3 and 4. Here we have two modes. فالmodes are 3 and 4 because 3 and 4 occurred 2 times more than all the other data. Or no mode. If you have, for example, 3, 4, 5, 6, there is no mode here because all the data repeated once or twice. Okay, if all the data repeated twice, then also there is no mode. The mode should be more frequent, should happen most frequently, okay, more frequently than all the other data. If you have two modes, we call the data or the distribution by model. One last thing to pay attention here when you deal with the mode is considered a measure of the center, but sometimes for some data, the mode may not be a value near the center. Really, it does not represent the center sometimes. Okay, so for example, if you look to this data here, what is the mode? If I ask you what is the mode, 3 is repeated 5 times, so the mode is just 3 because it's repeated 5 times, more than 16. طيب, what about the average? If you add all of these numbers and divide by 4, 6, 8, 11, because we have 11 numbers. If you divide by 11, you get 8.4. So 8.4 is the average. If they are already arranged, and we have 11 numbers, so 11 divided by 2 is 5.5. So the value number 6, 1, 2, 3, 4, 5, 6, which is 8 is the median, okay? And you will have 5 numbers to the right and 5 numbers to the left of 8. So the median is 8, the average is 8.4, which means the center is around 8, but 3 is not really the center. 3 is the smallest value in the data. Sometimes the mode is very weak measure for the center. Let us just solve this exercise. 3.2, compute the mean number of defects for this population of days. He said that it is a population. We have how many numbers? 8 times 3, 24 numbers. So n, small n is 24. Okay. I think this is not correct. It should be 24 days. It's not 8 days. Now, how to calculate the mean? Well, this is a population, so the mean is called mu, and summation x over capital N. Capital N is 24, and we add all of these numbers using the calculator.
Then above is also capital?
58, yes, correct. This is also capital because he said that it is a population. So it is 58 over 24, the total of all the data. So if you divide 58 by 24, you get 2.417. So that's the mean. Now compute the median number of defects. Well, to compute the median, I have to sort the data. So let me sort the data, start by counting the zeros. 3, 4, 5 zeros, okay? Then the 1, 2, 3, 4. Then 2, I have 2, 2, and another 2. Then 3, I have 3, 3, 3, 3, 3, 3, 6 threes. And for 4, I have 4. You don't have to arrange all of them. And if you want, we need to find the median. So if you find the median index I, capital N is 24, so 24 over 2 is 12. It is an integer, the position of the median would be position of MD is 12.5. The average of 12 and 13. Now, if you count the numbers, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it is in the middle between 2 and 3. The number in the middle between 2 and 3 is 2.5. You can just know it from looking 2 and 3, what is in the middle? It is 2.5, or you can find the average by adding 2 plus 3 and dividing by 2. So the median is 2.5. So the mean is 2.417. The median is 2.5. Determine if there is a mode number of defects. If you count the 4, we have 5 zeros, 4 ones, 2, 3 twos, but we have 6 threes. So the mode is 3. This is the most frequent number, most frequent value. I'll stop here. Inshallah, next time we will be able to answer this question, which is asking about the distribution, the shape of the distribution. Is it symmetric or skewed? We will find that next time. I stop here. Thank you very much. And if you have any question, please, you can ask.